digital computer, hardware parts of digital computer and their use, as well as logic gates. This video will be helpful for the semester 3 students of BCA course. So now first of all, let us see what is digital computer. It is a computer which has microprocessor as its central processing unit, or you can say CPU. CPU is combined with memory and I/O devices to form a digital computer. That means we can define a digital computer like a computer which has microprocessor as its central processing unit, which is combined with memory and input-output devices. Digital computer performs various computational tasks and it uses binary number system with two digits 0 and 1. This digit is called a bit. Next is a digital computer contains hardware and software. This hardware is usually divided into three major parts as memory, CPU and IOP, that stands for input and output processor. CPU contains ALU, registers and CU means control unit. So now let us see the use of these all parts one by one with the help of a diagram. This diagram is known as block diagram of a digital computer. So in a figure you can see that CPU is at the center, which has three parts: ALU, registers and CU. So now let us see the use of this CPU. CPU contains an arithmetic and logic unit for manipulating data. Then it contains number of registers for storing data and instruction. The registers are in between CPU and memory. They are used to store data and instruction temporarily. And control unit is responsible for fetching and storing the data, and it also responsible for controlling the entire execution of the ALU. Next is the memory. Memory contains RAM or ROM. It may be RAM or ROM. RAM means random access memory. Why it is known as random access memory? Because the CPU can access any location in memory at random and retrieve the binary information within a fixed interval of time. So this memory is used to store data and instructions, and the data may be input data or output data. So we can say that memory is nothing but the storage unit. Next part is IOP. IOP means input and output processor. It contains electronic circuits for communicating and controlling the transfer of information between the computer and the outside world. So input devices in a figure you can say input devices are connected with the IOP, and same way output devices are also connected with the IOP. That means as and when user enters something as data or instruction, then it is known as input and it is transferred with the help of IOP to the memory. Same way when the CPU has to display something as an output, then it is again transferred from CPU to output device with the help of IOP. So that is the use of IOP. So we can say these are the parts of digital computer and what is the use of these parts. Now next is logic gates. However, you can see that input devices, the examples of input devices are keyboard, switch, scanner, and you also can give the examples of output devices like monitor, LED, printer and others that you know. Now next is logic gates. You know that in a digital computer, data is stored in the form of bits 0 and 1, means in the form of binary. Now when you want to perform any operation on binary data, means you want to manipulate the binary data, then it can be done with the help of logic circuits, and that circuits are known as gates. Logic gates are basic building blocks of any digital computer, and it is an electronic circuit having one or more than one input and only one output. So a gate may have one or more than one input but only one output. The relationship between the input and output is based on certain logic. So now let us see some examples of some gates. Let us first of all see AND gate. What is AND gate? It performs AND operations, means its output is 1 or you can say true when all inputs are true, or you can say 1. It means if any one of the inputs is false, then its output is false. It can have n inputs where n is greater than equal to 2. Means AND gate must have at least 2 inputs, means minimum 2 inputs, but it can have more than 2 inputs. Now let us see the symbol and Boolean function of this gate. Symbol is, you can see in a figure, this is the symbol of AND gate with 2 inputs A and B. The input's name is A and B, and its output you can say y is equal to AB. This one is known as Boolean function. So this can be represented as y is equal to A and B and C and so on up to n. Y is equal to, you also can say y is equal to A dot B dot C and so on. You also can represent as y is equal to A, B, C up to n. Now let us see truth table. Truth table of this gate is how to, first of all, how to make this truth table. So as we can see that in a figure, this is the symbol of 2 inputs AND gate. So we have to make a table with title as inputs and output. It has number of inputs and it has only one output. So make 2 columns, one with the name inputs and another with the output. Now under input columns, you just find out how many inputs are there for this particular gate. So there are 2 inputs A and B. So make 2 columns A and B. Afterward, under the output column, write down the Boolean function, that is A into B. Then you have to find out the possible combinations of inputs. What combination can be entered as input? As we know that each and every input can have at a time value either as 0 or 1. So you can say that, let us see, you can say that A can be A can be 0 or 1 at a time. Same way, B can be 0 or 1 at a time. So when we want to enter the value of A and B, then we can say at the same time, at a time, A and B both can be 0, or A can be 0, then B can be 1, or you can say A can, if A is 1, then B can be 0 and both can be 1. So these are the possible combinations of input. Now question is that how to find out the possible combinations of the input. So there is a formula that it says that the number of possible combinations is equal to 2 raised to n. When n says the number of inputs. So in our case, n is equal to 2. So we can say 2 raised to 2, that says 4. So you can make 4 possible combinations. Now next, how to write down these possible combinations. So under this input columns, make that many rows. So we have to create 4 rows. So let's say this, the empty 4 rows you have to create. After that, what value you need to put inside these rows. So out of total 4 combinations, you have to divide this 4 combination by 2. So you can say 4 divide by 2, which is equal to 2. So for the first input, make 2 rows value as 0, 0, and for remaining 2 make as 1, 1. Then for the next B value, for the B value, find out how many times a value of A is 0. That says 2 times. Then divide it again by 2. So it says 1. So for the B, for 1 time 0, for 1 time 1. Same way here, 1 time 0, 1 time 1. So in this way, you have to make possible combinations. After that, put this value in this Boolean expression or Boolean function and find out the answer of AB as output. So let us say 0, 0. Then you can say 0 into 0, output is 0. If you say 0 into 1, output is 0. If you say 1 into 0, output is 0. And when you say 1 into 1, output is 1. However, there is a shortcut that how you can directly put the value as an output. So you just remember the definition of AND gate. It says that its output is 1 when all inputs are 1. That means from these many combinations, you just find out a row where the value of all the inputs, means here two inputs are there. So where the value of A and B both is equal to 1. So in this row, the value of all inputs is 1. So directly you can say its output is 1. In other rows, you need to put 0. So this is about the AND gate. Next, we also can draw a symbol and truth table for the three inputs AND gate. So let us say AND gate with the three inputs. What is the symbol and Boolean function as well as truth table? So you can say that symbol is the gate with three inputs and mention the name of inputs as A, B, C. However, you can give any name like say X, Y, Z, whatever. And then same way here you can say Y is equal to A into B into C. Or you can say Y is equal to A and B and C. You can say Y equal to A, B, C, A dot B dot C and truth table. So as I said, you have to make two columns, inputs and outputs. Under inputs, you find out how many inputs are there. So here three inputs are there. Make three columns with the title A, B, C and one output. As by mistake I have written here X, you can say Y. And then after that, find out the total possible combinations of inputs. So as I said, total inputs are 3. So possible combinations is equal to 2 raised to 3, which is equal to 8. So make 8 empty rows and then fill up the rows one by one. How to fill that row? For the first input, divide total combination 8 by 2, which is equal to 4. So for the first input, 4 rows, put 0, 4 rows 1. For the second input, find out the value of first input where it is 0. So how many times 0? 1, 2, 3, 4. So 4 rows are there. Divide it by 2. So it becomes 2. So for the second input, 2 times 0 and 2 times 1, 2 times 0, 2 times 1. And same way for the third column, means third input, find out the value of B where is 0. How many times 0? 1. How many times 1? 2 times. So 2 divided by 2 becomes 1. So put C 1 times 0, 1 time 1, 1 times 0, 1 time 1 and continue like in that way and then put the output. So as I said that output of AND gate is 1 when all inputs value is 1. So in this combinations, from these combinations, you can say that this is the row where the value of all inputs is equal to 1. So directly put its output as 1 and in remaining rows, means in other rows, you put output as 0. So this is about the AND gate. Next time we will discuss the other gates. Thank you.